In this video, we are going to look at why the 802.11 Wireshark lab is so important in real world. This lab helps you to see how Wi-Fi actually works behind the scenes, how devices connect, authenticate and exchange the data. It also teaches you how to troubleshoot Wi-Fi problems, analyze signal strength, understand the wireless security and identify the issues like interference or failed connections. These skills are extremely useful in networking, cybersecurity, and IT support because they give you ability to diagnose and fix the real wireless issues instead of just guessing. Before we start the lab, the important thing to understand is monitor mode. Capturing raw Wi-Fi frame is not easy. To capture real Wi-Fi signal, we need something called monitor mode. Monitor mode allows your Wi-Fi card to listen all the wireless traffic signal in the air, not just your own network. You need two devices to capture frames, the one which generates the traffic and another for capturing. Then it shows the real 802.11 frames like beacons, probes and data packets. But most Wi-Fi cards on Windows do not support this. If you are using Windows, we will provide you pre-captured frames which you can use for your lab. In this part of the lab, we are going to explore sample Wi-Fi capture in Wireshark. When you open the trace in Wireshark, you will see the different types of frames like beacon frames, data frames, acknowledgement frames, and probe request. But our main focus is data frame because data frame is actual frame which carries information over the air. When you click on any frame, you will see it divided into several layers. The first one is frame. This is the extra information added by Wireshark, things like arrival time, capture length. This is not real part of Wi-Fi packet. Now the next is radio tape header. This layer comes from your Wi-Fi card in monitor mode. It tells you the channel, signal strength, data rate, and the other physical details. The next is IEEE 802.11 header. This is the real Wi-Fi header that was actually transmitted over the air. It includes things like addresses, sequence numbers, and security information. This is the most important layer. We will explore it in detail. The last one is data. This is the payload inside the frame, but in real networks, it is usually encrypted with WPA2 or WPA3. This is just a simple overview. In the next step, we will break these layers down and understand how Wi-Fi communication actually works. Now this is the most important part of our lab, the IEEE 802.11 header. If you want to understand how networking actually works, you need to look behind the scenes. When you send any traffic, whether it's a message or a video, it doesn't just fly through the air magically. It's wrapped inside a digital envelope. That envelope is called header. Let's open it and start with the first major section, frame control field. Frame control field is basically the ID card of packet. It tells us three things. The first is variant. The variant is right now 0. It tells us the current version of 802.11. The second is type. This tells us the general category of the message. Type 0 for management frames like acknowledgement, RTS or CTS. They clear the channel for data transmission. Type 2 is for data frames and they carry the actual data. Then we have subtype. Subtype tells us specific types of frame. For example, if it is a management frame, is it a beacon frame or a probe frame? Let's move to the flags field. This is where the real logic happens. These flags control how devices talk to each other. First we have two DS. DS means distribution system. It means your router or access point. This flags tell us the direction of travel. 2DS means you are uploading to the router. From DS means you are downloading from it. Next we have more fragments. So it tells this is the last fragment. It means this is a complete frame, not a piece of larger message. Then we have retry. The retry flag is off, which means frame is not a retransmission. The power management flag is off. It tells that the device is not in sleep mode. The next is more data flags. This flag is also off, so the access point do not have more data waiting for this device. The next one is protected flag. It tells us the data is protected, usually with WPA2 or WPA3 protocol. And finally, the order flag. The order flag says the frame is not strictly ordered. These flags are like traffic rules for Wi-Fi, helping devices and send and receive data efficiently and safely. As we cover the flag field, now move to the next section. The first thing you will see is duration. It tells other devices that how long the channel is busy. It supports the virtual carrier sensing and avoid collision. The next is address field. The most common address you will see receiver address, transmission address, and BSS ID. Then we have sequence number. Sequence number is used to reorder frames and avoid duplicates. And the last we have frame check sequence. This is a 4-byte CRC used for error detection. Now let's move to the physical layer, which we can see through the radio tap header or 802.11 radio information in Wireshark. Let's expand it and see. In our sample trace we are using 2462 MHz frequency. You can see here, and we have channel 11, and this is channel 11 in 2.4 GHz band, and this is very common Wi-Fi channel. And then if you want to see data rates, you can see we have a column here called rates. You may see different data rates like 1, 6, 12, 24 and 54 Mbps. These data rates depend on the distance, interference and signal quality. And then we have RSSI, another column. RSSI is the signal strength, and this is measured in dBm. Minus 52 dBm, you can see here minus 67 dBm. But if you want to compare these two frames, minus 52 and minus 67, the minus 52 has better quality than minus 67. And then we have noise level. It tells us how noisy channel is. And then we have SNR. SNR is simply signal minus noise. As you can see in our sample, we have signal strength minus 67, noise level minus 91 dBm, and SNR is 24 dB. And 24 dB means the signal quality is excellent. The physical layer detail help us to understand how Wi-Fi behaves in real environments. Now we separate all the frame in that sample using different filters. We use the simple filters to separate data control and management frames. We use filter for data frame. You just type here wlan.fc dot type equals to for data frames. You will see all the frames, all the data frames, and you can see the percentage of data frames here, and it's less than 50%, 47.8%. For control frame, you just type 1 instead of 2. You will see all the control frames, and the percentage of control frames are 37.3%. And for management frames, just type 0 and hit enter. You will see all the bigger frames and other management frames, and the percentage of management frames is 14.9%. If you have noticed, only about the half of the traffic is actual data. The rest is control and management frames which are needed to coordinate communication. This shows that Wi-Fi spends a lot of time for management the network, not just handling the data. Next, we check how many frames are retransmitted using filter. You simply type here WLAN fc.type equals to WLAN dot fc dot retry equals 1. Hit enter. You will see that these frames are retransmitted, and it includes the data frames and management frames. Now we will look at management frames. First are the beacon frames. To see the beacon frames, use filter WLAN dot fc dot type underscore subtype equals 8. Press enter. As you can see here, these are the beacon frames, and access point sends these beacon frames every 102.4 milliseconds. These beacon frames include SSID, spotted rates, channel, and capabilities. Beacon frames are transmitted at 1 Mbps, so even far devices can receive them. And then we have association frames. When a device wants to join the Wi-Fi, it follows these simple steps. Device send an authentication request. Access point replies with authentication response. Then device send association request, and access point replies with association response. If you want to see association frames, you can use filter WLAN dot fc dot type underscore subtype equals 0. Hit enter. You can see association request. And the last we have probe frames. A probe is a request, basically the device asking is the network is available. Access point replies with a probe response. Devices use probes to reconnect quickly, scan for networks, and discover known SSIDs. If you want to see the probe request, simply type filter WLAN dot fc dot type underscore subtype equals 4. Hit enter. You will see all the probe request. If you want to see the probe response, just hit 5. You will see all the probe response. These management frames are used to discover and make connection with Wi-Fi network. So in this lab, we looked behind the scene of Wi-Fi communication. We learned how wireless traffic is captured, how Wi-Fi frames are structured, and how devices discovered and connect to the network. By analyzing IEEE header, signal strength, data rates, and management frames, we saw that Wi-Fi is much more than just sending the data.